Okay, so now let's look at a couple of examples using logarithmic differentiation to find dy dx. So for the first one, example 6, we want to find dy dx whenever y is equal to the square root of 4x plus 7 times x minus 5 cubed. So first thing we need to do, so take the natural log of both sides of this equation. So natural log of y is equal to the natural log of this whole thing, square root of 4x plus 7 times x minus 5 to the third power. And then rewrite this using our log properties. So left hand side is pretty much going to stay natural log y up until we differentiate. The right hand side now, using our natural log properties, we can rewrite this as 1/2 natural log of 4x plus 7 plus 3 natural log x minus 5. Again, remember this is using your logarithmic properties from algebra. There's a sheet in Moodle. If you don't remember these properties, make sure you take the time, go back, memorize these properties. All right, so now let's implicitly differentiate. So derivative of natural log of y, we have to use the chain rule. So natural log of blah is going to be 1 over blah times the derivative of the blah. So 1 over y times dy dx equals, and now differentiating the right hand side, so 1/2 times derivative of natural log of 4x plus 7. So the derivative of natural log blah, 1 over the blah, so 1 over 4x plus 7, times the derivative of that 4x plus 7, which is 4, plus 3 times the derivative of natural log x minus 5, so 1 over x minus 5 times 1, again using the chain rule. So we have 1 over y dy dx equals, now cleaning this up a little bit, so that gives us 2 over 4x plus 7 plus 3 over x minus 5. And so we can go ahead and get a common denominator. So 1 over y dy dx ends up being 2x minus 10 plus 12x plus 21 over the pair of these denominators, 4x plus 7 times x minus 5. And so we have 1 over y dy dx equals 14x plus 11 over 4x plus 7 times x minus 5. We want just dy over dx, so we're going to multiply by y. But remember, what is y? Y is the square root of 4x plus 7 times x minus 5 to the third power. So we don't want to just say this is y here. We want to actually multiply, so dy dx, we want this entire derivative in terms of what we would have gotten if we had tried to do this explicitly. So we're going to multiply it, so 14x plus 11 over 4x plus 7 times x minus 5 times now what y was, so square root of 4x plus 7 times x minus 5 to the third power. So let's clean that up. So dy dx, so we have 14x plus 11 times x minus 5 squared, because one of those x minus 5 cancels with the x minus 5 in the denominator, over the square root of 4x plus 7, because we had a 1/2 power with that square root in the numerator. 1/2 minus 1 gives you the negative 1/2. And we're done. That's all you can do. You could, if you wanted to really badly multiply that all back out, you could do that, but you don't need to, because remember, it's going to be easier to work with in this factored form. All right, so the last example, example 7. So we want to use logarithmic differentiation to find f prime of x if f of x is 5x minus 4 to the third power over the square root of 2x plus 1. So the first thing we want to do, we want to replace f of x with y. So y is equal to 5x minus 4 to the third power over the square root of 2x plus 1. So now take natural log of both sides, so natural log of y equals natural log of all this stuff, so 5x minus 4 to the third power over square root of 2x plus 1. Now rewrite the right-hand side using our logarithmic property, so natural log of y equals 3 natural log of 5x minus 4 minus 1/2 natural log of 2x plus 1. Now let's differentiate. So 1 over y dy dx is equal to 3 times 1 over 5x minus 4 times 5 minus 1/2 times 1 over 2x plus 1 times 2. So 1 over y dy dx equals 15 over 5x minus 4 minus 1 over 2x plus 1. And so cleaning that up, so we end up 1 over y dy dx equals 25x plus 19 over 5x minus 4 times 2x plus 1. And so now we want to multiply both sides by y to get dy dx by itself. So dy dx is this 25x plus 19 over 5x minus 4 times 2x plus 1. All of that times our y, which we said y was the 5x minus 4 to the third power over square root of 2x plus 1. And so then cleaning this up a little bit, we end up dy dx is equal to 25x plus 19 times 5x minus 4 to the second power over 2x plus 1 to the 3/2 power. And you're done. Now, I should mention, if you were to solve that original function, f of x, which we want to rewrite this and call this now, instead of dy dx, call it f prime of x. So if you were to differentiate this original f of x function using the quotient rule and then your two different chain rules inside that quotient rule, and then simplify all of that, you should end up at this same answer at the end.